This is NO3M. I'm going to demonstrate an automatic antenna tuner for 630 meters. The antenna's a top-loaded vertical, resonated by a series coil and capacitor. The coil is larger than necessary, so the series variable capacitor, in this case a vacuum variable of 1000 picofarads, is used to cancel the additional inductive reactance and bring it back into resonance on 630 meters. The vacuum variable is driven by a 1/2 RPM DC gear motor. The control circuitry is based on a system by W5GJV. However, my implementation differs in the phase detector used. Ralph W5GJV used a phase detector out of a military tuning unit that was available surplus from Fair Radio sales. Likely no longer available, and there are some issues with this particular type of detector, which is known as a Foster-Seeley discriminator. It can be used for FM detection, etc. One issue is the DC output indicating the phase error between the voltage and current varies with the RF power applied. Another issue, at least with the homebrew implementation that I tried, was that the toroid for the T1 pickup transformer was saturating with as little as even 100 watts. Of course, that's understandable with a small number of turns on the secondary. So instead of using this phase detector, I chose to use a simple diode ring mixer type phase detector. This particular schematic is from M0BMU's document, which also includes a scope match. And this is a nice phase detector in that the clipping diodes on the voltage sense circuit limit the RF applied to the mixer, essentially giving a nearly constant DC output for the phase error regardless of the RF input, at least from about 20 to 1200 watts according to M0BMU. And it's a relatively easy circuit to build. There's the actual circuit. We have T1. Center tap provides the polarized DC output indicating the phase error. BAT85 Schottky diodes for the clipping on the voltage sense input. The capacitor samples the RF voltage and actually shifts it 90 degrees. There's our diode ring mixer. I've matched quad of 1N4148 and transformer T2 center tap ground. The output of the phase detector then goes into a circuit similar to W5GJV's using an op-amp, which is a 2904. Again, my circuit's a little different because we're dealing with a single-ended phase detector output instead of a double-ended. And the amplification factor of my op-amp circuit is somewhere around 8. Then the output of the op-amp is fed into a pair of comparators, which is part of a 2903 comparator. One to sense a positive DC voltage and one to sense a negative voltage, and independent set points on when their outputs are triggered. They have open collector outputs. They can sink approximately 16 milliamps. So we use high sensitivity, i.e. high resistance relays. And for my particular build, the relays are 12 volt 1000 ohm coils, so they only consume about 12 milliamps, so we have plenty of overhead from the open collector outputs of the comparators. Now my implementation is wired a bit different than W5 GJVs. I use a pair of double pull double throws wired in a way that basically inverts the polarity on the floating control lines to the DC motor down at the antenna feed point. And here's the actual circuit on a breadboard. We have our op amp here, meter adjustment pot, and we have a 1 milliamp zero center meter. Back on the breadboard, we have the comparators, the set point pots, double pull double throw relays, and LED indicators whenever either one is activated. Dual rail plus and minus 5 volt supply using a 24 volt center tap transformer, which basically with the center tap grounded is 12012. Diode, full wave bridge rectifier with 1N4001 diodes, and a pair of regulators, 7805 for the plus, 7905 for the minus. And we're also taking the 12 volt output from the full wave bridge and using it to apply to the motor control line. And as mentioned before, the double pull double throw relays essentially just invert the polarity to drive the motor in one direction or another. So let's go ahead and see this thing in action. Right now we're in 474.25. Let's go ahead and transmit. Alright, 165 watts, 1.07 SWR, and basically a zero phase error according to the control system. Now according to the vector watt meter, we're pretty much there. Our phase error is about 0.5. 54 ohm resistive match. Of course the resistive match is not automated. Eventually it may be, but that has to be manually switched down at the antenna. So let's see what happens when we tune off. We're going to go ahead and tune down the band while it's still transmitting, and we're going to watch the phase error meter. Let's see if we can get a good angle here when one of the relays kicks in. Right, we see the phase error, and there it brought it back. Now sometimes it overshoots a little bit. And there we go. And let's check our phase. Right now a phase error of 1. Alright, let's tune it up the band. You can see obviously tuned off. And it's bringing it back slowly. There, it overshot a little bit the other way. but SWR is still pretty good, 1.12 to 1. And the phase error is only about 0.4. Resistance a little high. Now we can manually tune the system. We have a switch that can disable the automatic tuning, and we can manually tune it with this unit. Quantum mode chokes on the motor lines. Just basically a double pull, double throw, center off switch that inverts the polarity on the motor control line. Obviously we don't want to be manually tuning if there's any chance that the automatic tuner will kick in, or we'll end up shorting one supply or another. So, and that's the automatic antenna tuner for 630 meters. I'll give it one last go here. There we are. About 0.8, 0.9 degree phase error. So, works pretty good. Next part of the project, maybe try to get the resistive match automated. That's going to be a little more complicated. Initial thought is to actually break open the PTT line to the amplifier, because we don't want to hot switch the relays down at the antenna to select the appropriate transformer taps. Of course, we could use something like a roller inductor for an auto transformer, but I've done that in the past, and not the most mechanically reliable thing. So, alright, that's it for the automatic antenna tuner demo. This is NO3M. Thanks for watching.